All right, the last thing we need to talk about in this lesson is how to do nth roots. So this is really where complex numbers in the polar form really help, because this is so much easier and doable when you're in polar form. So here's the deal. When you have an nth root, this looks all complicated. If you look at just like this portion of it though, it should look like the power rule, because if nth root is the same thing as raising something to the 1 over nth power, taking the nth root of r would be the same thing as r to the 1 over nth power. And then you're just multiplying your theta by 1 over n, which is where you're getting theta over 1. Okay, so nothing's different except for this last little section right here. The only reason that's there is because depending on your root, you're going to have a certain number of solutions. So if I'm doing a square root, I have 2 solutions. If I'm doing a cube root, I'll have 3 solutions. If I'm doing a 4th root, I will have 4 solutions, and so on and so forth. Okay? So the reason we add 360 over n, or you can do 2 pi over n, depending on the problem. I'm just making my theta a degree, so I'm saying that's a degree. So each of our solutions should be equidistant from each other around the whole circle, which is why we divide by the number of solutions. The k right here just represents an integer. So k will equal something like 0, 1, 2, 3, or however many times you need to go until you find all your solutions. So don't let this scare you. We're really just using the power rule, but then we're finding other solutions. Okay, so let me show you what I mean by that. Now, to make it a little simpler, I am going to have you just do your argument in degrees. I think it's easier to do it in degrees. But if you don't feel that way, that's fine. So right here, we've got a square root. That's going to tell us we have 2 solutions. So that's important. Okay. We need to convert in order for this rule to work. So remember, this is our x, our y. So I'm going out 4 and up 4. So let me make this bigger. I learned my lesson last time. Out 4, up 4. So right there, so it should be an isosceles triangle of 4 by 4, which tells us we have 4 root 2 as our radius. I'll put that in the front. And then our angle, since we're just in the first quadrant and this is isosceles, has to be a 45-degree angle. Perfect. So nothing too crazy at this point. So remember, we're taking the square root. So let's go ahead into solution 1. So solution 1, you would just take the square root of 4, square root of 2, and then you're going to divide 45 by 2. So square root of 4, and then the square root of 2, I'm going to split that up. This is 22.5 degrees. So square root of 4 is 2. Now, square root of a square root of 2, you can write the square root of the square root of 2 as 2 raised to the 1/2 raised to the 1/2. Well, if you just use your power rule right here, exponential rules, you just multiply those. So this will be 2 and then the 4th root, because it will be to the 1/4 of 2. And I don't know why I changed colors, but you're welcome. And then we got our 22.5 degrees. That is solution 1. But remember, we have 2 solutions. And the 2 solutions have to be equidistant from each other. Okay? So, remember, a full circle is 360 degrees. So I'm going to add half of 360 because I have 2 solutions. Or I'm going to add 180 degrees to my solution to find solution number 2. So solution number 2, everything else will stay exactly the same. Your angle is just going to be 202.5 degrees. And there is your second solution. Nothing too crazy. All right, let's do another one. Okay, cube root here. Cube root means we're going to have 3 solutions this time. Let's do our quick trick to convert this. Remember, we're going to use degrees. So quick trick. It's nice, since this one has a square root of 3, it's good to know which one's the long side. So our long side's the one with the square root of 3, so this is our short side. I'm going to go positive along the x-axis the long way. And then I'm going to go down a short distance, -2. I like to exaggerate the long versus short. So this is 2 square root of 3, and this is -2. There's our angle. So we're using net values that should be values that are in your unit circle. Otherwise, you'll have to do the inverse tangent function. You could use that because this is your theta. But if you recognize that this is the long side, short side, this angle is actually going to be 11 pi 6, which is the same thing as 330 degrees. And then if you recognize that this is a special triangle, the x root 3, this is x, this should be, I should not write it that way. That makes it look like it's 2x. Oh, this is the same thing as x. So this side should be double the length of whatever x is. But I'm going to do the absolute value of it. So this should be a radius of 4. Okay. So our radius is 4. Our theta is 330 degrees. So we have 4 cis 330 degrees. And we are taking the cube root. Let's find solution number 1. Cube root of 4, by the way, is just cube root of 4, so that's nice. And then we're going to do 330 divided by 3. And that will be 110. So we've got the cube root of 4 cis 110 degrees. So solution number 2, remember all of these are equidistant. There are 3 solutions. So we're going to split our full circle into 3 equal parts, or into 120 degrees. So you're just going to add 120 to that solution. So we got the cube root of 4 cis 230 degrees. Third solution, you're going to add the exact same amount. So we get the cube root of 4 cis 350 degrees. And there are your solutions. Now here's the reason it wouldn't make sense to keep going. If you went one more and you add another 120 degrees, you'll get 470 degrees. 470 and 110 are coterminal angles. At that point, you've just repeated yourself, so you don't keep going. Okay, so there are your solutions. This is pretty sufficient. If you feel like you've got it, great. I have one more example where it's on an axis, or on one of the axes. Wow. Nothing too crazy, so feel free. You can stop now if you want. You can continue on with me if you want as well. Fourth root. 4 solutions. Super easy. Let's convert. The nice thing about this is there's no x values. This is 0 minus 81i. So we're going down -81, meaning our radius is 81. And our angle, theta, is 3 pi halves, or in degrees, 270 degrees. Nothing too crazy. So we got 81 cis 270 degrees. And we are taking the 4th root. So let's go to solution number 1. Solution number 1, you'll take the 4th root of 81, and then you're going to take 270 degrees and divide it by 4, which I think is like 67.5, yes. So 4th root of 81 is 3, and then this is 67.5 degrees. So there is solution number 1. Now, remember, we have 4 solutions we need. So we need to split our full circle of 360 degrees into 4 equal parts. So we're going to add 90 to each one. So our second solution would be 3 cis and then 157.5 degrees. Boom. Then we do our next one, third solution. We're going to take 3 cis and then we're adding 90 degrees again. So we get 247.5 degrees. Boom. I love it. And then our last one, our 4th solution, would be 3 cis, and then you add the 90 degrees as well, and you get 300, that looks like a weird 3, 337.5 degrees. And you are done.